Hey guys, we're going to look at day 7 notes. We are going to do more geometric sequences. This time we're going to look more from the table and word problems side of that. So let's look here at number 1. It says, makers of Japanese swords in the 1400s repeatedly folded and hammered the metal to form layers. The folding process increased the strength of the sword. So here we've got a table and it says number of folds on the top. So that represents our ends, fold 1, fold 2, fold 3, fold 4, and fold 5. And then the number of layers that we would have is our f of n, which is the bottom row here, which is 2 layers, then 4 layers, then 8 layers, then 16 layers, then 32 layers. So the first question that we have here is this a geometric or arithmetic sequence, and how do we know? So first let's talk about how do we classify something as geometric or arithmetic. So remember, geometric has an R, a common ratio, and that comes from multiplying by the same number every single time to get to the next number. Arithmetic, on the other hand, has that common difference, which came from adding or subtracting the same number every single time to get to the next term. So what we need to do is we need to look at the layers, this is where our sequence is, and say, well, how are these numbers changing? How do I go from 2 to 4? How do I go from 4 to 8, from 8 to 16, and 16 to 32? So if we think about from adding or subtracting, first we should realize that this would be increasing, so not subtracting. If I go from 2 to 4, that would be adding 2. From 4 to 8, that's adding 4. So those are not the same numbers, so I know that cannot be right. So I know it's not arithmetic. So let's see if it's geometric. Can I multiply by the same thing every time? So to go from 2 to 4, we could multiply by 2. From 4 to 8, we could multiply by 2. 8 times 2 is 16, and 16 times 32 is, 16 times 2 is 32. So I see that here I have the same multiply every single time, so I know that it is geometric. So we're going to say that it's geometric because we multiply by the same number every time, each time. Okay? So, therefore, now that we know it's geometric, we're going to write the explicit formula. So that means we're writing the explicit formula for a geometric sequence. So that would look like we need the first term and that R value. Well, the first term of this sequence is going to be the first term. So this is going to be a 2. Our common ratio, on the other hand, that is how our number is changing. How do we go from one number to the next number? Well, we multiply by 2 every time. So our explicit formula would say a sub n equals 2 times 2 raised to the n minus 1 power. Okay? And now I want to find for C, I want to find a sub 15. So this means we're going to plug a 15 in for the n into the explicit formula. So a sub 15 equals 2 times 2 to the 15 minus 1 power. Okay? When we type this into our calculator, we're going to do 2 times 2 raised to the 15 minus 1, or you can just put 14, and we're going to get 32,768. 32,768. What is that representing? That's representing the number of layers. So this would be layers. Okay, after 15 folds of the metal, there are going to be 32,768 layers. So we could write a sentence for that if we wanted to. We'll write a sentence for the next one that we do. So number 2 here says that the table shows the number of houses in a new subdivision. Is the table linear or exponential? So what I'm asking here, is it changing by adding or subtracting the same thing every time, or is it changing by multiplying by the same thing every time? Okay, so notice if it's linear, that's going to represent arithmetic. But if it's exponential, it's going to represent geometric. Okay, so we're going to come over here to our houses number, which represents the y's, or the numbers of our sequence, and I'm going to say, how do we go from 3 to 6 and from 6 to 12 and 12 to 24? Are we adding the same thing every time? Are we adding 3 every single time? No, but we are multiplying by 2 every single time. So this one would be exponential. Okay, because we're multiplying by the same thing every single time. I probably should put over here that it's multiplying so you guys know it's multiplying by the same thing every time. So let's write an equation that would model the table. So when I'm asking for an equation, I mean the explicit form. Okay, so that means we need the first term, which is 3, and we need the common ratio, which here is 2. So a sub n equals the first term, which is 3, times your common ratio, which is 2, times, or to the n minus 1 power. Okay, so this is our equation. And then I'm going to ask you, well, how many houses will there be in 10 months? Well, what do you think this 10 months is representing? Well, if we look over here, we see the word months in the table. So months seems to be representing which term. So this is going to be our n. So we want to take the n and plug a 10 into it from the explicit form. So a sub 10 equals 3 times 2 to the 10 minus 1. So let's plug it in. 3 times 2 raised to the 10 minus 1. And we're going to get 1,536. 1,536. Well, what is this representing? This is representing the number of houses. So here it said the number of houses. How many houses? 1,536. So we could write a sentence for this. After 10 months, the subdivision will have 1,536 houses in it. Period. Make sure you capitalize your sentence and put a period at the end. Okay? So, I want you to pause the video right here. Go ahead and try number 3. It wants you to look at the tables and just figure out if it's geometric. If so, you're going to state the recursive formula and the explicit formula. Alright, so now you should be back from pausing it, and we're going to figure out together, is this geometric, yes or no? So in order for it to be geometric, we need to multiply by the same number every time. So if I want to go from 1 to 4, we have to multiply by 4. Okay? If I multiply 4 by 4, I do not get 7. So this is not geometric. Okay? So I cannot keep going. Well, if you look at it, it's actually arithmetic because you could add 3 every single time. So that one would be arithmetic. Okay. On your number A, you'll notice that there's no lines. These should, oh, they're both number A. This actually should be number B. There should be fraction bars on each of those. Sorry that did not get printed for you guys. Okay. So we want to figure out for this one, is it geometric? So on here, to go from 250 to 125 might not be as obvious. So let's use that little trick that we did, which said take the second term, 125, and divide by the first term, 250. If we take 125 and we divide by 250, it's going to give us 1/2. Okay, so let's say if we multiply by 1/2, we should get to 125. Is that going to hold true for the second one? Well, if you take 125 and multiply it by 1/2, you definitely get 125 divided by 2. So we know that this is holding true. So this is geometric. So yes, geometric. So now we need to find our explicit and our recursive formula. So our recursive and our explicit formula. So we need the first term, which is 250, and the common ratio, which is 1/2. So my explicit would say a sub n equals 250 times 1/2 raised to the n minus 1. Your recursive, you should have two different pieces. You should have the first term stated, and then you should have the a sub n equals a sub n minus 1 times 1/2. Okay, so those are the two pieces you needed to do on that one. Okay, then let's look at number 4. This one's going back to a graph. It says the graph shows the number of players in the first 4 rounds of the U.S. women's single U.S. Open tennis tournament. Okay, so the graph is for the women's singles. Okay, so part A says we want to write an explicit rule for the sequence of players in each round. I'm not sure where this A100 came from. It looks like I've got some words that got moved around on this page. Sorry, guys. So we want the explicit rule. So let's come up with a table to represent this, kind of like we did in the other problem. We got our x and y. So x's are here. So my first x, when it's 1, my y is 128. When my x is 2, it's 64. When my x is 3, it's 32. When my x is 4, it's 16. Okay? So again, this is the sequence. The x's are just going to tell us which term number. So 128 would be the first term in the sequence. So a sub 1 is 128. What would the common ratio be? Well, how are we going to go from 128 to 64 and 64 to 32? Well, let's do our little division trick. This is half. Does that hold true for the next one? 32 over 64? That's still 1/2. So our r is 1/2. Our explicit formula will say a sub n equals 128 times 1/2 raised to the n minus 1. Okay, so how many rounds are there in the tournament? Okay, so I need to find out if we kept going with this pattern, the last round will only have 2 players in it. So I need to find out how many rounds there's going to be. Okay, well, let's write out what we have. We start with 128 players, okay, for the first round. So this would be round 1. Okay. If we lose half of the players, or half of the players are eliminated each time, the second round we said had 64. That's round 2. Round 3 is going to have half as many of those people. Round 4 is going to have half as many as those. Those are what we currently have. So we want to keep going. Let's half 16. That's 8. Half 8. That's 4. Half 2. This is going to be the final round. Well, if this was the 4th round, then 8 was the 5th, 4 is the 6th, 2 is the 7th round. So there will be 7 rounds. Okay, so the tournament will have 7 rounds. All right, so you guys should now be able to move on and start working on the test review, which is actually the homework that goes along with the day 7 notes, because your test is coming up on Friday.